So in this video, I'm going to demonstrate how are we going to model the frame structure for set 4 using SAP2000. So medyo hindi na extensive yung discussion here. If you want an extensive discussion, you may refer to the videos videos set for set 1. Mas mataldal ako doon kasi mas ang assumption ko doon is relatively new topics lahat. So ang focus ko doon sa subsequent sets natin pag nagde-demonstrate na ako ng modeling is more on diretsong input parameters na. Alright? So less talk, less explanation. If you want more talk and you really want to understand yung context, no? May mga context din akong binibigay dun sa discussion sa set 1. I recommend or I'd refer you to the video sa set 1. No, both in beams and frames. No, magkaiba kasi 'yon. So sige, start na tayo. Bale to start, you open your SAP 2000. Ulitin ko lang, version 14 ang gamit ko. Ang latest version is at version 23 point something na. So 23 point something na. Anyway, same naman yung interface. Medyo naka-dark mode lang ako. Mas maganda syempre yung interface ninyo kasi mas bago 'yon. Pero yung model na mabubuo ko dito, pwede nyong i-run sa inyo. Pero yung model na mabubuo nyo, hindi ko pwedeng i-run sa akin. So, yun lang naman yung disadvantage ng lower version. Anyway, before you start, set first your units here sa bottom right-hand corner ng window. Sineset ko siya to kilonewton millimeter by default para maging consistent dun sa units na na nilalagay natin yung given na units, no? Para maging consistent siya, I use kilonewton millimeter and then GPA. Right? Then you click or press Ctrl N or click the create new model. So, we're gonna use, ano bang magandang gamitin? Frame na kasi to, so grid only yung magandang gamitin. So, ngayon, we have to define yung grid system natin. Again, X direction is along the horizontal dimension. Z, ngayon yung kukuha ng elevation. Si Y ngayon yung out of plane. Okay, may reason dyan. I've extensively discussed it in the previous videos kung bakit XZ plane tayo nakatingin. But for now, let's just apply that and identify the number of grid lines that I have to define per direction. Okay, so I'm gonna set my origin at A, and this is my x-axis, positive x, and this is my positive z-axis over here. So, to determine how many stations I need to define, ang nagde-define nun is typically yung nodes, no? Kung saan ka nag-define ng nodes. So, this one is 1, 2, and then 3, and then 4. So, I'm gonna need 4 stations. So, okay na to. In the y direction, since plane analysis to, so 1 lang dapat yon. And then z direction, elevation naman yon. So, this is 1 at this level, and then this is 2 at this level. So, 2, I need 2. And then, yung spacing along X, that must be equal to L, which is 2 meters. Sa Y, doesn't matter kasi 1 lang yung station yan. Hindi yan lalabas. And then sa Z, 1,000 yung isa-set ko because L over 2 yung nakalagay dito. Alright? Okay. Alright. XZ. I think ang magiging origin ko ata is ito. Hindi pala yung A. Ito yung magiging origin ko. Okay. So now, I'm gonna have to change this. Kasi, iba yung spacing natin sa gitna. So, to change the coordinate system, you go to the Defines tab, and then click Coordinates, and then Modify and Show System. So, dito natin papaguhin yon. So, the first grid, it's okay, no? 2,000. The second grid is at 3. And then the fourth grid is at 4. Alright. So, we're good with this. Alright. Yeah, this is better. So, yung grid system natin will serve as a guide lang para madali nating ma-model or ma-snap yung element natin dun sa grid lines natin or grid system natin. Alright? So, next we define the material properties. Okay? So, for the material properties, define material properties, add new material. And then, okay. So, it's a good habit na nagpapangalan, nagre-label tayo accordingly. So, dito, E, A, B, C, D, ang gamitin ko. neglect self-weight. And then this one, we can just simply copy yung value na compute na dito. So this one is in GPA. So make sure that the set unit is in kilonewton millimeter. Okay, so tatlong window at tatlong field lang yan. Yung name label, yung zero self-weight, and then yung Young's modulus. That's it. Click OK. And then add yung material ulit for member BD. So this one is for BD. Again, zero self-weight. Zero self-weight over here. And then this one, we can refer to the pre-calculated values dun sa Excel sheet natin. Copy-paste. Okay. Okay. And then define the section. Okay. So we have to define first the material properties kasi pagdating sa section properties, nililink natin yung material sa section agad. So we're gonna use yung general option, no? Kasi we don't have to, well, technically, wala talagang binigay na height with thickness. Walang shape even, no? Hindi natin alam yung shape ng cross-section natin. So for those types of problem na ang binigay lang is yung section property, you can use yung general option. Alright? So here, i-encode mo na lang yung mga section property. So for A, B, C, D, that was classified as frame element. Therefore, may value yung A. So, pasukan natin yung value ng A. And then, yung moment of inertia, ipapasok natin sa moment 3. Then, set the rest to 0. Click enter. And then, baguhin natin yung pangalan to F, A, B, C, D para alam natin later on, no, kung kanino natin siya i-assign. So, select mo ngayon yung appropriate, okay, material property. Then, click OK. Then, add new property again for the second section. Okay, so ganun ulit, general option. This time, BD is a truss element. Therefore, ang kailangan ko lang ipasok dyan is yung cross-sectional area, which is 3,000. And then the rest are 0. And then, pangalanan na lang natin ng FBD. And then, we have to select the appropriate material properties, EBD. Okay, okay. Okay, then we draw the frame. So, starting with F, ano ba? Ulit. Starting with, okay, select muna natin yung proper section, no? A, B, C, D, E. A, B, C, D. So, A, B, B, C, C, D. Then, right-click. And then, select na natin si BD. So, BD. And then, escape. Alright. And then, next, boundary condition. So, since, ano ba yung boundary conditions ito? Fix at A. Okay, fix at A. Assign joint restraint. Fix at A. Pin at D. Assign joint restraint. Pin at D. Alright, ano pa? Yung special connection. Okay, moment release sa BD. Okay, so assign frame release. Start is my moment release cuts the start. Okay, okay na ba tayo dyan? Hindi pa. Kasi, although naka-pin support siya dito, pag, iba yung pin support, iba yung pin connection. Okay? So, pwede kasi mangyari na homogeneous o rigidly connected itong dalawang element na to, which is pin supported. Nagagets? Okay. So, ibig sabihin, currently, naka-rigid connection pa tong dalawa. So, kumbaga, yung rotation nito, magro-rotate din ito. Okay. Kumbaga, hindi to truss element. So, to disconnect yung dalawa, putulin natin yung moment transfer niya. Then, kailangan yung release ay both ends kay BD. Para ma-ensure ko na truss element siya. Ayan. So, this way, it's okay. Okay. Pwedeng pwede rin namang ito yung i-release mo, yung end. Pero hindi pwedeng parehong naka-release. Okay. So, ito rigidly connected. Okay na tayo dyan. So, that's how we model the moment release at B. Next is yung loading. Okay. So, sa loading, we select the segment kung saan tayo mag-assign ng frame loads distributed. And then, uniform load siya equivalent to omega. Omega is 40 kilonewton meter. So, 0.04. Gravity, yeah. Sige. Okay. So, 0.0. Kilonewton millimeter. Okay. So, now we're done. Okay. Then, we go to analyze. Set analysis option to plane frame na XZ plane, and then click OK. Click again yung analyze. Wait lang, nagahang. Alright, let's wait for it to be okay. Okay. So, analyze, set load cases to run, iset yung modal na hindi natin i-run, and then run now. Okay. So, while waiting, you know na tapos na yung analysis if this one is locked. Okay. So, pag nakalock na yan, ibig sabihin may results ka na. Now, you will also know na it's done kapag nagpa-prompt na siya ng pangalan. Okay. So, for this case, this one is for frame. Right? Alright. Okay. So, ito na yon yung results. So, pag nakalock na yan, may results ka na. Tapos na yung analysis. Now, if you want to modify anything sa model mo, then you have to unlock this. Tsaka ka makapag-modify. So, sige, ito na tayo sa results, no? I'm just gonna set the option windows to 4 windows kasi marami akong gustong tignan. Okay? Meron akong gustong tignan na deform shape. Perhaps in XZ plane. This one is okay. So, if I look at the deform shape, yung BD ko is straight. Seems straight, right? So, it's okay kasi na kukuha niya yung behavior ng truss element which is before and after deformation, straight pa rin yung member. So, okay na tayo dyan. Nakukuha yung zero slope dito, okay. Nakukuha yung rigid connection dito, okay. Okay, so the deflected shape looks fine. So, we have to check naman the other portion. So, una kong chine-check is yung joint reaction. So, for the joint reaction, I usually look at it in 3D. Bakit? Kasi para makita ko yung moment. Lalo kung may moment reaction yan. So, para makita ko yung direction ng moment. Ayan. So, itong eyeglasses na to, perspective lang yan. No? I mean, may parallel, may perspective view. So, bahala ka na mag-set. Anyway, ayusin na lang natin ng konti yung view. Ayan, nang sa gayon nakikita natin lahat. So, now, before, or sige, set na rin natin to to XC, and then set na natin siya to moment diagram. So, moment 3, show value, and then this one to shear diagram. Shear 2, value. Masyado maliit. Lakayan natin yung scale para ayan. I-auto mo na lang. Ayan. So, ito na yung makikita nating diagrams. Now, we wanted to compare it side by side with the results of our analysis over here. So, starting with the joint reactions first. Kasi mukhang dun tayo, yeah. So, dito, si 8, 9, 10, yun yung sa fixed support. So, XYZ, that's 23, positive, positive, and then positive rotation. So, we're getting the values. Okay, that's good. And then, the pin support reaction. So, negative X, positive Y. So, we're getting the right reactions over here. So, we're good. And then, if we want to compare naman yung shear and bend, internal force diagram, we refer to this one. Okay. So, sige. I-plot ko muna to, no? Manually, para rin makita nyo ano ba yung kino-compare natin na side by side with this. So, sige. Side by side natin yung result ng SAP over here. So, we have a negative shear, 56.05. Yes. And then, how about this one? 23.95. Yes. 30 point, how about this one? 30 point, anong value nito? 30.292. Yes. And then sa dulo, meron kang ito ay 49.721. Yes. Magkakaiba lang ng sign. So, sa shear diagram, good tayo, no? So, uniform, linear, linear. Pagdating sa moment diagram, ano yung napapansin nyo? We're getting the same values. So, negative moment, negative rin. We're getting the same values, but the plot is opposite, no? It's because sa bending moment, meron tayong tinatawag na moment diagrams on tension side tsaka compression side. So, by default, si mga structural analysis software na sa tension side sila nagpa-plot. Ay, ang natutunan natin sa libro, compression side. So, just untoggle this. Uncheck mo lang to. Ibig sabihin, you wanted to plot the moment diagram sa compression side. Then, it will now look the same. No? Halos, oh yeah, pareho na. Okay. Now, kung naalibat-baran din kayo dito, kasi mukhang straight line na I want, pero gusto nyo smooth line, there's another way uh, to smoothen this curve. I-unlock muna natin yung project. Wait lang, naghahang. So, unlock muna natin to, and then may change tayong parameters. Okay? So, okay. So, we select yung mga element na may um, uniform load. Kasi kung nasa yung uniform load, definitely pagdating sa moment diagram, second degree curve na yan. So, hindi na yan straight line. Curve na yan. So, ito yung dalawang line na yon. And then, we assign frame output stations. Dito, parang ang ginagawa mo lang dito is parang nagsiset ka ng finer discretization sa element. Not necessarily you define nodes, pero parang ang gusto mong mangyari is interpolate niya ng mas masinsin between two nodes, yung element, yung values in an element. Okay? So, pwede mo palitan yan to 20 to pwede ka mag-set ng mas mataas if you want it smoother. Alright? So, sa ngayon, I think sufficient na yung 20. So, click OK and then run the analysis again. So, run now. And then wait. So, pag nag-clock na to, ibig sabihin may results ka na, lalabas na rin yung result mo dito. So, dapat mag-smoothen na siya. Ayan. So, as you can see here, mas smooth na ngayon yung curvature niya. Right? Hindi na siya yung parang patse-patse na line. Okay? So, yan. You can do that. So, parang inano lang, sinisinsinan mo lang yung discretization sa element na to without necessarily defining a node. Diba? So, yeah. That's one way to smoothen the curve. So it now looks like the moment diagram that we have set up here, right? And it checks out, right? Am I right? So let's check. Okay, ito is 84, yeah. 846950. We have a maximum moment here. So nilalabas din niya to, 11.55. Yeah, we already determined that. We also have a potential maximum here at 7.20. Sa kanya, 7.23. I think hindi yun yung maximum. If you want to determine the maximum, paano mo mag-determine ng maximum? Ako, ikot-ikutin ko lang to. Hanggang sa makakuha ko ng pinaka-maximum. Well, maximum na pala yung pinapakita niya. 7.23, 22. Okay. So, pwede mong sinsinan pa. Kung gusto mo ng sobrang maximum talaga. So, kunyari, sige, sinsinan natin na i-exaggerate lang. Tignan natin kung lalabas yung 7.25. Assign frame output station. Run analysis, run now. And then wait. Medyo tatagal yan because masyadong madaming element, I think. Ayun. Ayun, lumabas na. 7.25. So, kung gusto mo talagang makuha yung maximum na value, then yeah, sinsinan mo yung discretization sa element na to. Okay, so lumabas yung 7.25 and lumabas na din yung 11.55 over here. Alright, so that's it for set 4 frames. Okay, if you have any questions and clarifications regarding this, or if you want me to debug your model, for example, you try to recreate this on your own, and then hindi siya nagma-match dun sa solution mo, and you wanted me to debug this particular model, then I suggest na i-export nyo siya as text file, S2K. So, ang ibato nyo sa akin is yung .s2k. That way, mabubuksan ko siya. Kasi hindi kompleto kapag SDB file lang yung ibibigay nyo sa akin. So, export nyo yun. And then, kayo din, kung nagpapasahan kayo ng files, better to pass it in text form or text file, S2K, tas import mo na lang siya. No? Import mo na lang yung text file na yun. That's a better solution. Okay? So, yeah. If you have questions, don't hesitate to ask with regards to modeling. So, ensure nyo muna na verify nyo na or medyo confident na kayo, no? Sa paggamit ng SAP kasi gagamitin nyo yan sa project ninyo. And it's a good practice, no? Na mapakita nyo yung mga values or ma-recreate nyo yung plane frame. So, at least confident kayo na nagagawa nyo siya. Kumbaga, walang question sa modeling skills nyo. Ang magiging question na lang or magiging problem nyo na lang is yung how to use the output or the results of the analysis.